So I'm very pleased to introduce Ian Anderson, whom most of you know. So Ian got his PhD from engineering science here in 1996, and has worked in industry and academia for a number of years. So it's been a design engineer at Fishman Vehicle Whitewave. His work at DSIR and IRL, designing hip implants and stuff like that. He then joined the University of Auckland as an academic in 2000 and was one of the founding members of the ABI in 2001. So he heads the biomimetics lab and is exploring stretchable electronics for wearable sensors, soft robots, and electroactive polymer energy harvesters. So in 2012, Ian and a couple of his former students, started StretchSense, a spin-out company where he is now a director and chief scientist, and that's working on in the area of soft and wearable sensors. So Ian's other passion is fin propulsion, and he's a keen advocate for that. So together with his lab, he's developed and raised the fin-driven human-propelled racing submarine Taniwha, which is what is going to tell us about today.
Thanks a lot, Vinod. And thanks a lot for coming along to this talk. So I'll tell you about an adventure that started about 3 years ago, where we first, where Taniwha began. You passed Taniwha on the way in. Much of it is, much of it's new. Some of it is still goes back to the original days when we first built the thing, for our first submarine. And I'll take you through that period and what we learned along the way. So, the motivation for this talk, I'll cover the history from 2013 to 2016, our changes from year to year, and I finish off with the European International Submarine Race and our trophy, and some of the adventures we had during that week when we were competing for the European trophy. But starting off with the motivation, we are motivated to try and learn from the way fish swim. Propeller propulsion is ubiquitous in human devices, but fin propulsion is ubiquitous in living things in the sea. And the interesting thing is to see just what one can do with fins. Can we supplant them, replace propellers with fins, and what are the advantages? I discovered we've just purchased a remotely operated vehicle, a little ROV, and it has a couple of propeller thrusters on it, and I've been trying it out. And if it gets anywhere near weed, the weed gets stuck in the propeller. So I've discovered already advantages for having a fin. Fish never get caught unless they open their mouth and grab a hook. But the propulsion system is able to slide around, to go through rocks, go around weed and not get caught. But when your propeller's nearby, it gets jammed. The weed gets wrapped up and it stops going, and you have to haul in the line to get it back. That's a whale shark at Ningaloo Reef in Australia, photographed in 2007, I think. Very quiet, stealthy, and beautiful to watch. So here we have two things that I'm going to sort of bring to you. One's the concept of the bending body, and here's a seal at near Lee, off the coast of Lee, just north of here, and it's incredibly maneuverable with its ability to bend around as it swims. And next to it, we have a leather jacket fish, photographed very close to where this one was photographed, and you can see it has its dorsal and ventral fins, which are wave-like and are propelling it forward, and it has the back third of the body tail bends around, and basically it's when it's not traveling very fast, it uses the back of its body as a like a rudder, and its ventral and dorsal fins as a propulsion. So starting with the actual leather jacket, so we have a horizontal plane bending of the tail, and we have the dorsal and anal fins for propulsion. This is a nice separation of the two different planes, as you'll see, in terms of a submersible, in that you're able to basically your yaw is just entirely in this plane, your propulsion's in that plane. So the whole saga really started back in 2013 with respect to actual submarine devices, when I visited the International Submarine Race, the United States race, at the Naval Surface Warfare Center in Carter Rock, Maryland. It's held in a tank that's about 1 kilometer long, but they only used about the first 100 meters of it for the race. And it's a straight line race, one submarine at a time. And you can see some of the different technologies here. This is the University of Bath. That's Minerva, and that is a propeller submarine. It has a counter-rotating propeller. Most of the submarines, about 24 of them there, were propeller types. Then we have the submarine by Rheinval. They are always, you always meet them at these races, and they always turn up with something really, really off the planet. It's called River Shark, because of course Rheinval's right on the Rhine. So, and this one kind of slowly made its way to the bottom and stopped. And the other one that really stood out was the one from Carnegie Mellon. And this is actually a tank, and this guy's backside sticking out of it. They actually they changed the rules after this race to stop this from ever happening again. Because they were because they were actually the best performing Finn submarine. So anyway. So back in 2013, we started working on the Taniwha, and we got I found a report that was compiled in 48 or 49 by the Navy Department, which was, they tested about 12 different solids of revolution, each about 3 meters long, in the David Taylor Model Basin in Carter Rock. And that's where that race was just held. That's where the American race is held, in the David Taylor Model Basin, this kilometer-long tank. And they produced these nice curves. They showed you how to build the thing, and we had curves of Reynolds for different Reynolds numbers, drag coefficients. And so we thought, well, we just grab one of those models and use that for the basis for the Taniwha. However, what we did was we took that model. I forget which number it was, and we then squashed together the back of it to make it so instead of having a solid of revolution coming to a point, it was extruded out to form the basis for a tail, for a hinged tail. And because we had trouble getting it, we were based on the 6th floor, getting in and out of the lift, we made it shorter so it would fit in the lift. But it was still the same model. It was model 4154 from Carter Rock, yeah, with those two modifications. We did a mock-up of it in board and aluminium strip, just to see what it looked like and start to put things together on it. And this was up on the 6th floor. We're working away there and cut these actual sections using the data from the Carter Rock model. Oh, by the way, the reason why the Navy Department commissioned that report was they wanted to, they were preparing the way for the new fast submarines. World War II submarines were really just boats that went underwater. They were very, very inefficient, very poor hydrodynamics. And if you look at the U-boats or the American subs, they were just basically surface ships that sank. Their top speed was about, I think, about 7 or 8 knots, something like that. Whereas the fast attack submarines that came after that, getting up to 20, 30, 40 knots underwater. So they were wanting to start to understand how to design these things, and that was what that report was based on. And out of that came the USS Albacore as the first post-war fast submarine. I don't know if it was the first, but it was probably the most famous of the fast submarines after the First and Second World War. So anyway, we had to make this hull, and we used the services at CACM, the Center for Advanced Composite Materials, and we used a double bagging technique where you actually, the mold was made by Jackson Electrical. They have a very large mill. I think they have the largest mill in New Zealand right now. So you could basically just take this foam blank and hollow out, scallop it out, so you now have a mold for the hull. Then with the double bagging technique, you put a bag down, then you put some spaces in there, put the other bag down, suck it, then you suck the resin through, and you get a nice shape using vacuum of the hull. Do this twice, you get 2 halves, you put them together, you've got a hull. And here's the rest of the procedure. You've got to make sure you paint it with release agent, then lay down the glass fiber and prepare for the second bag. And cut the second bag, place it on the mold, seal it with putty, vacuum draw, and epoxy resin into the interbag space. I was very nervous during this whole time because I'm extremely allergic to epoxy resin. Just the smell of it makes me nervous. And I managed to avoid breaking out during this period. If I touched a doorknob and it was slightly sticky, I immediately went off and washed my hand very carefully. Okay, so the sub then and now. Back in 2013, we chopped the end of it off to have a see-through nose cone, and here's the sort of looking into it. All wooden frame inside. Cords for the control surfaces, for the controllers, string cords. We have the double Hobie Mirage drives. By the way, you can see these on the harbor as people are fishing. You see somebody fishing in a kayak, and they're not actually doing this. They're holding their rod, but they're still going forward. It's because they're pedaling their feet. And so we took 2 of these, and we modified the pedals so that one pedal operated the top set of fins, and the other pedal operated the bottom set of fins, and there was a cord connecting the 2. So you just do this, and both did that. Okay. So moving forward to 2016, we took this hull, modified it substantially, and I'll be talking about our flexible tail, about the entire internal new chassis, braking mechanism, safety buoy mechanism, bullet nose cone. We had a flat nose, like a hemispherical nose cone here, moved to a bullet nose cone. I'll go into all that, but that's basically what we had. So immediately after building this thing, we tested it. You can see it's quite raw looking. There's no paint on it. We cut a couple of windows so the operator, the pilot, could see where they were going, which didn't really work all that well. And we had this was at the dive pool in Iraqi, and it's just about. And he touches the bottom there, and says, "Oh, I can feel it." Let it drift, okay. So one of the nice things about direct fin drive, this is that you're pedaling and there's a bicycle chain that goes straight through to the fins. You can actually feel if they touch something, you know you've hit something. You can't do that through a gearbox and a propeller. And you notice that we're basically steering this thing. We have these dive planes here. That was a problem. We learned a lot It took us a year and a half to sort this out, but we had our dive planes in the wrong place. I'll come around to that. So, basic concept, thin shell that can be easily opened up, internal chassis that supports systems, and the Hobie Mirage drive fins. And we also had ballast tanks. This was my one of my contributions, and it actually won us an award in the last race in Carter, Maryland in 2015. But we got rid of them because they were a pain in the neck. They kept on. Essentially, what you did was you moved water from the front to the back, or the back to the front, and air would get displaced the other way, and you could then trim it. You could trim it inside. And we had little pumps to do that with. But we discovered that once you got this kind of set up really nicely, you didn't need them anymore. So they were kind of in the way after that. But that was the 2013 submarine. Then we went to the EISR, European International Submarine Race, in 2014. Now, there's two races. There's an American race and a European race. We've just been to the European race. Next year is the American race, followed by the European race. Each 1 year out of step. So we went to Gosport, which is just down in southern England, across the water from Portsmouth, where the Bounty sailed from. You all know about the Bounty? Okay, good. And that's also where they hung a couple of the mutineers a couple of years later, after they found them, and they came back in the after Captain Andrew Andrews found them. Anyway, we actually made a bit of a hit there. They liked our submarine, the local press, but it had serious problems. It didn't work that well, and I'll tell you why later. The ultimate prize for this, which is over there, is the EISR trophy, which depicts Alexander the Great in a see-through diving bell being lowered into the Mediterranean. This is a long-standing legend that he did this. I don't believe he did, but never mind. Officially, he's the first European in a diving bell. So that's what's inscribed on the trophy. And the course was in the QinetiQ, spelled with Q's instead of K's, QinetiQ tank in Gosport, which is about the size of a football field in area underwater. 120 meters long, 60 meters wide, and about 5.5 meters deep. And what you do is you start off and you go through, here's your starting point, go through timing gates, turn left, come back through a slalom, and then finish the race. That's the basic race. Here was the team that was there at the time. Ryan Chow, undergrad, he was at engineering science. Ben Pocock, our engineer. We had former interns, Dominic Appel, Daniel Volkizer. That's Anthony Harbus, mechatronics student who's now working with StretchSense. Oh man, I can just have a look at it. Marcus Thompson, who is a Kiwi living in London, and free diver, and myself. And there we are with Taniwha, and there's the front fins where they were. And here's some of our competition. Bath, Michigan, ETS, Montreal, Plymouth. These are all propeller boats. This was actually a two-man submarine here. ETS, Team Omer, that is. There's the Rhine-Wall submarine. This is the one that was presented at, this is the team that had the double Marlin drive. They modified it for this race. And there's the University of Warwick submarine. And here we are. We discovered immediately we couldn't get it on the lift. We had to take one fin off because it wouldn't quite fit. So when we discovered, so the next day we chopped both fins slightly shorter so it would fit on the lift, which the elevator took you down. There we are. There's the guys getting into position, getting ready to race. We basically, all of our divers in the water there. There's actually a control, the control people are over here. They're watching monitors with underwater cameras to see what's going on. And there's a hydrophone system that tells you what to do. They can ask you to move, get it up to the start line. And here's just, some of you may have seen this before. I'll just play this video again. Here we are. Finally getting the camera. The camera will come up right in a second. There you go. And there's Daniel in the, our pilot. And the support divers get out of the way, and he's off. And what you, if you listen carefully, after it gets out of, hang on, wait a second. There should be a grinding sound coming. There's a bit of a grinding. Essentially what he did was he then crashed into the bottom and sort of stayed on the bottom. The problem was, and we had the forward dive planes, when you started to nose up ever so slightly, you had to respond very quickly to get them to bring you back. If you were hesitant, the entire body would behave like a dive plane. And it would just get worse and worse and worse and do this, or it would just do that, and then stay stuck to the bottom or head for the surface. This was a major issue we had. Very hard to keep it stable. I'll come back to that. There was lots of repairs. Having those cords to pull things around were a real hassle. They would break, and we had many aborts. In fact, everything we did, we never made it round the course. There's Daniel in the, these are the UK Army divers, and they're bringing him back. And here's the team bringing the submarine back. And here's how we performed. Tuesday, Wednesday, Thursday, Friday. That's as far as we got. And you can see that Thursday was our best day. And at this point, he's crashed into a ladder and couldn't, there was no reverse gear for this thing. You just went forward and that's it. So he was stuck. And he was holding on to the cord, the broken cord for the rudder, trying to steer the thing. It was real hassle. So we learned a lot from that. So we had reliability issues, cords were breaking. Stability issues, sub would head for the surface or grind against the bottom. Now, the stability issue, a fundamental one. Our dive plane was at the front. So when it started to nose up ever so slightly, it would then, you get positive feedback. Just get worse. Put the dive plane to the back, if it nosed up, you got negative feedback. Try to lift it back again, see? It works the other way too. Which is wonderful. It meant that we had stability. So basically, there is a tension between stability and maneuverability. Fish are up here, submarines should be back there. Fish have got a fish brain, a sophisticated balance system. They can respond quickly, and they can correct quickly. But submarines need stability. So, 2014-15 changes. We also had a blunt nose. We went to a pointed nose, more like what was originally on the plans for the 4154 model from Carderock, from the David Taylor Model Basin. The reason why in 2014 at the EISR we had this nose cone was it only cost $300. To go to this one, I had to have a mold made to do it. This was just naturally just air casting. This required to be pushed into a mold. So we decided on the basis, we did some hydrodynamic modeling, found that it was a good idea in terms of, I think, 10 or 15% improvement in drag coefficient to go for a bullet-shaped nose. And so I paid for the mold for that. We also went to hydraulics, no more cords, and we also needed to test. So here we are in 2015. Here's a movie of the test in the Parnell Baths. You can see there's no cover on it, so you can see Chris's his backside poking out, and we're trying to steer this thing, and it was showing promising signs at this point. We were getting better control over it than ever before. We had the dive planes at the back, so I can now. We learned we needed a deeper pool, so we found the West Wave dive pool, and here we have a really good run. You can see it's going straight and true. Then the bloody hatch comes off. We eventually fixed that problem. We found a way to make the hatch, if the hatch can't come off, it won't come off. And so we found a way to make it can't come off. And it's stayed on and through all the races in Carderock. So basically a 2015 submarine last year. There it is, Hubby Mirage drives. It still had the balance tank, still had the buoyancy tanks in it rather, but it now had the dive plane at the back, and it had hydraulics to control the dive plane and to control the rudder as well. And so we went to Carderock, Maryland, and here's the team with Korai, Garrett, Ben, Sanjay, Chris, and myself waiting outside. We got this nice bullet-shaped nose, and there's our big dive plane there at the back. We were ready to go, and we getting ready for inspection. You have these little tents outside that you can then prepare the submarine. Here's some of our competition. We had these fellows here that tried to copy our overall scheme. They had like a Taniwha-like front. They'd obviously seen us on the web. Guys from Montreal. Here's the Rheinval submarine and University of Warwick's submarine, and this one was from a Dutch university. Okay, moving on. I'll just quickly, I won't labor those too long. Most of them were propeller submarines, although the Dutch one was a fin type, but the fins are running in this plane, so more of a in the sort of dolphin plane. As with the Rheinval submarine, the dolphin, rather in the horizontal plane. So here we go, looking at the beach. They call this the beach back here, where all the essentially the submarines can be sitting. It's very crowded, and there's about 23 different teams. And looking in the other direction down this kilometer-long tank, we only did the first 100 meters of it. And here's one of our starts. Now I'm just going to slightly move it forward here to, here we go. So we're just getting it ready to go, and you'll see it taking off straight and true. This guy at the back here is going up to tell the fellow at the surface that we're ready to go. Then we're off, and it was beautiful. It's rather murky in there. This is a really old tank, and of course, through the week, it gets more and more harder to see where you're going. But it's well lit, and it's only a short course. So here we are. We got first single-person non-propeller with a top speed of 3.65 knots. We completed 10 of 11 runs. We had one failure when the cord that connected the top and bottom fins got jammed. And on the very, very last race, the last second of racing, we had a king hit from a Navy frogman who punched a hole in the, in the nose cone. My $2,500 nose cone.
Why did you do that?
Well, he just grabbed it, and it wasn't. I don't think he really. I'm saying he punched it, but essentially he went to grab it. They were really nice guys, but his hand went through the very thin extruded acrylic of the nose cone. And anyway, my job was to tow the submarine back, and as I was actually on the surface at the end of the race towing it back, and typically the guys in the inflatable from the Navy divers would always say some nice things about how well our submarine was doing, which made me feel really good. So anyway, first thing, 2015-16 stages, get rid of the ballast tanks. We got rid of them, although that was very painful for me because I spent a couple of months trying to seal them for water. Made smaller, sleeker dive planes. This is a much sharper dive plane. We have an elevator at the back, and our hydrodynamic modeling indicated we'd have a nice stable submarine. We thought we had to give this thing brakes because it seemed to indicate that on the new rules that you had to stop within a certain distance. And so we had these, if you've ever seen a sailplane, a glider, where if you wanted the air brakes on a glider, you pull a lever, and out from the wing pops the brakes on the spoilers on both sides. And so one of us actually was a glider pilot, and he designed this brake that would actually just pop out on both sides. And our modeling and our testing indicated there was a good solution for stopping it. Here's just to prove that we actually produced a model. There it is. The brake popped out. And I think the really neat thing that was produced was our bending fish-like body. So this is one of our guys, Garrett Becker, developed this articulating tail, which is covered with this neoprene skin. And the nice thing about it is that it's a 1 degree of freedom action. Essentially, there's like a single hydraulic cylinder which operates this nice curved actuation, this fish-like motion. Just 1 degree of freedom. So here's if you can actually see it outside, all the controls. We have a safety buoy. There's a safety buoy. If a dead man's handle, release it, and the part of the lid you'll see will pop up, and this buoy will go to the surface to let the. By the way, here we're getting ready for the European race now that we've just attended. The Army divers will then come down and get you when this buoy pops up, indicating that this is a problem. We have the tail cylinder. So here's the tail. There's the hydroplane cylinder. The braking mechanism was clever. We brought these two things together, and they would both pop out. So there's cylinders this way. This is a sliding mechanism here. So we had basically, with Chris's two arms, able to do all of these actions that would operate the submarine. And we also had one other additional thing, a pilot breathing monitor. This is something that part of Chris's PhD project is to give us the ability to sense what divers are doing, or the diver health monitoring. So here's a stretch sense sensor, and he's breathing, and the little bar goes up. I can show you a nice video of this thing in operation. So here he's got a wetsuit with monitoring the arm movement, and he's also breathing, getting his breathing rate. So we've got that working underwater now. So what we did was we had the ability to put a light on the submarine on the outside, so we could tell the guy was alive in there. Essentially a condition monitoring for the machinery of the submarine. And getting to the actual test now before we went, here's the test of the whole system. And everything's working. We were still, we didn't have our fast release clips at this stage, so we used duct tape, and I was able to turn the thing around. Actually Sanjay's turning it around, trying to stop the bloody thing, and it then crashed into the wall. But we were ready to go. We did not break that nose cone. Fantastic. You're a third European International Submarine. So we're back to Gosport again. You know what the race course was like. And just I'd like to just play this for you. This is the official video. And this gives you a picture of all the teams that were there. That's the race director, William McGill.
From all over the world who've come to race their designs, put their engineering method to the test in what is a fairly unique sporting event.
Go, go, go.
That's the Dutch team, Wasub. They were the fastest. They're the world record holders for speed.
How he's doing, and he's pretty calm under pressure, so we're pretty happy about it.
It's propeller driven with mechanical steering to the left and right, and up and down, and to compensate the roll,
There it is.
electric gear.
They start with a CAD exercise, got to get their boat, they're going to make their decisions about their propulsion systems, their control systems, their shape of the boat, all those sorts of things. They're going to make all those decisions as a team.
So the whole thing about the gradable is the most 3D printed sub here on the grid, which will see massive technology advancements for us as a team. Very few adjustments to water buoyancy, and also the steering actually goes straight down when we want it to. Our hull is made of carbon fiber, circular motion pedaling system, and electrical system.
They were also Hobie Mirage.
The idea behind this one was to reduce our mass quite a bit so that we could accelerate more quickly onto the line. And she turns on a dime, so that's good.
Basically, your hands are right up by your chest, so you can move some handles, and your shoulders are tight up against the actual hull.
And it's not great visibility, and you're not a fish, so your brain doesn't like being laid down in water.
So our drivetrain became decoupled from our propellers, so our propellers aren't really turning when we are turning. We aborted like 10 feet off of the start. We're going to fix this right up and then we'll be going again.
That's the scoop.
Yeah.
Oh, hey, Jay. Oh, that's 50 points.
I looked at the pole and I just ran straight into the That slalom course, it's a bit of complication. It's how wide you can take a corner and still get into the slalom course.
Brand new teams have never done this before.
Our hatch kept popping open, so we're just fixing, doing some quick Velcro, adding some quick Velcro patches.
We had a really low budget of only 3,000 euros. I think we got the cheapest submarine to this whole place.
And then we have the best teams in the world, the record breakers.
That's the world record holder.
So we have the whole range. It's fabulous.
How that's supposed to be there.
Okay, so that's the. I'll just quickly show you the pilot side view. We actually this is our own video. On the day before the race started, on the Friday, we actually put a GoPro camera on it and took around. Was it Friday or Monday?
It's Friday.
It was Friday, yeah, and just showed you what it looks like to go around this thing, following that. And there you go, through the timing. This is actually 5 times speed, so not that fast. It turns around and then comes back through the slalom. Now the slalom got worse day by day. They put the poles further out, so you had to make sharper and sharper turns. Okay, so I'll show you how he did on that. You see the divers come in at the end. Here we go. Watch this. That shows you how fit we are. Come down. These are our guys coming down to get it. So here, anyway. So there's the other fish sub, Omer, ETS. They also used a Hobie Mirage drive, but they had a bicycle drive inside. They had some trouble with that. And here's the. I've just taken because they were also using the Hobie Mirage drive. I put them alongside us. And Wasub 6 was the really fast one. But just wanted to demonstrate that here's we're going 2.3 knots, took 167.1 seconds to complete the course with zero faults on this run. And this is 1, 2, 3, 4, 5 in that day, on that Monday. 3 on the Tuesday, and 4 on the Wednesday, and 4 on the Thursday. Notice here that essentially we did not have, during racing, we didn't have a single abort. On the Thursday, we hit 4.7 knots. Thursday morning, we thought we had a world record. In fact, the guys at the race said, yeah, it's a record. So I'll tell you what we did after we found out what we thought we had the world record. So here's how. I just want to show you that we can actually steer this thing. This is on the worst course, I think, when the last day when they were furthest apart. So now he's going around. Now he's entering the slalom. He's following that line down there. You can see it. Goes around that one. Now he's got to go all the way over here to get around the next one. And it gets worse. So he's now he's got to slow down substantially. This is Chris Walker slowing down to get around the next one without touching it. Now the ultimate challenge is to get around the last one. I was looking at it instead of aiming the camera. I apologize for that. He's just going to go around the last one now. He's going to go through here. It's quite a challenge. This is me, the Army divers following him. There you go. So now here, I was just sent this by Sir Robert Hill, who's the chief judge. This is a picture of the actual video. So now we're at the start. We had to tell the guy that we were ready to go, and you had to get into the camera. So watch this. There you go. We're ready to start. And you'll see another interesting problem developing here. Okay, off she goes. One of our runs. Okay, correct. Bring it back. Then we come to the first timing gate. Okay. This is the first timing gate right here. That's real time. That's real. That's no speed. That's real time. There he goes. Second timing gate. Notice it's sort of porpoising a bit. Then he comes up to the very end. This is the end after the slalom, and race is over for that one. So Thursday morning we broke the record. Afternoon we went shopping because we had the Friday black tie dinner, and we had a good feeling that we'd done something special, and we thought we were going to get somewhere. So we had to get bow ties and white shirts. What we found out Thursday evening was that we hadn't broke the record. That the data was the record was actually 4.9. We had to do 5 to break it. So what happened was we had 1 day left, and the final day was the agility competition, which is twice around the course. Twice around the course meant that we had to go from a 5-liter cylinder to a 10-liter cylinder inside the submarine. And the boys wanted more speed. They wanted to try and get this record. So they wanted to try and kill 2 birds with 1 stone. I told them, I said, I don't think they should. They should not try and change anything on that submarine because they're doing really well. We're ahead. So what did they do? I went out to get coffee for everybody. I came back, and well, there's the 10-liter bottle. That's what's expected there. And there's all this stuff on the floor here, like this. This is being shaved sharper. Well, that's fine. But then I noticed that the dive planes were shorter. They actually chopped them off. And you'll see that they've gone from like that to that on both sides, you know. And so now this is interesting. We saw the porpoising going on there. What was going to happen at high speed with shorter dive planes? Didn't know. But still, there was the goddess of speed. They wanted 5 knots. And so we tried to get it. And so here's the Friday results. Twice around the course. Taniwha 2. We actually didn't do too bad. We didn't get any faster. That 10-liter bottle was hard to pedal with that extra volume in the submarine. So, but still, we're doing pretty well placing there. The Wasp clear was faster. There was another boat that was fast. There was another two boats who were faster than us. So I'm just using the same comparison as before. So it's a bit unfair that I haven't put them on there. But I thought I'd just give you three comparisons there, two other comparisons rather. So the final results, we got the trophy based not entirely on speed, but on reliability, a report, and presentation. They scored you for all these different things, but we were the second fastest submarine there, and we didn't have a propeller. We've demonstrated that you could go fast and be maneuverable without a propeller. We got the overall trophy. You can't see that here, but we also had the best propeller performance and reliability trophy, best non-propeller and reliability. Okay, so we actually got three trophies there. But I brought down the one to show you of the overall trophy. And here we are with Rear Admiral Phil Greenish, who presented the trophy to our team, all with our white shirts and black ties. And so just before I completely wrap it up, I'd just like to say thanks to our sponsors, Air New Zealand for flying the Taniwha there. Dive New Zealand magazine's been great supporters for us, and they've been covering providing information to the diving people about what we're doing, and also helping us to get into the boat show. Global Dive West Haven giving us helping us with equipment. Jackson Electrical Industries giving us our mold and also other support in the races. Main Freight brought the have helped us to get the submarine there and back. Bodyworks Panel Meeting, they're just down the road there, by the way. We didn't have we lost our sponsor for the painting, and one day we were wondering what are we going to do about this. So Chris said it was a panel meter just a block away. So we walked down the block down Wakefield Street to Bodyworks, and they said, "Sure, we'll support you. Just bring it down." So it was really nice. So just sort of walked down the hill, and there was a Taniwha painted. And they also, what we delivered to them, actually after they put the primer on, looked more like the surface of the moon. They got it nice and smooth, and gave us a nice finish. Pope Packaging produced the crate. Sequel Wetsuits gave us wetsuit support, plus that nice skin that went over the tail. And last but by no way least is the University of Auckland, our own Bioinstitute, giving us a place to work and support to help us get there. CACM and the Department of Engineering Science giving us support. So with that, I'd just like to say thanks.
Thank you, Ian, for this fantastic talk. We do have some time for questions. Good.
Ian, considering that the fast fish all do it by waving their tail, have you considered developing your flexible tail as a passive mechanism?
You know, yes, in fact, yes. But for that to work, you need to have more flexing going on in the body. If you look at a fish, it actually starts at its nose and creates a vortex that
These are just technical challenges.
can get lift from, and then yeah, exactly. It's a serious technical challenge. I mean, I've seen other submarines that have tried that, but they sort of end up doing something like this, and not going very fast. You really need to have a completely bending body to do this. So the compromise is to have the something like the leather jacket with each of the fins is instead of doing this, we're doing that, and then use the body as a rudder, basically. That was our compromise.
What about the battle skirt?
Yeah, that's an interesting point.
It's going to be lying like that, so we can bend that way and not that way.
We thought about that too, but the thing is that the Hobby Mirages worked very well the first time we used them, and we thought we just continue to develop that. But that's an interesting point, because if you are doing whale type movement, my guess is that, well, if you look at the way whales steer, their body just rotates, and so essentially they're sort of doing this. Then if they want to go that way, they turn around. They turn that way. They roll. We didn't want to roll, so it kind of made sense to stay with the propulsion in the vertical plane.
Well, yeah, the control becomes much more complicated in either case. I think if you're doing it, either this or this, much more complicated than what the situation you have.
Yeah,
The steer.
exactly. And essentially, it's a compromise. You have to. And like I said too, it's the whole stability thing. We originally had the little fins at the front, but we didn't have a fish brain to use it, so we had to go for stability.
What do those seals do, yeah?
What's that?
How fast are seals on the water? They look pretty impressive in the zoo tank.
Incredible.
I frankly don't know.
How easy it is to replace parts? For instance, they sawed off the back stabilizers. How easy is it, if you want to put it back in the water? How easy is it to put a new piece on?
Actually, on the day they sawed them off, they assured me they could just glue them back on again, or just screw them back on. I really got really annoyed about that when they did. You're talking about what we're going to do from here?
Yeah, and how easy is it to modify, or what would you like to modify?
I think the way forward is to make the hull smaller. Really, we have room to. We have too much room in there at the moment. I think we could make it a lot smaller, because your profile determines your drag. Get it down to say 3/4, and your drag's down. You've lost. You're down to 3/4 of the drag. So that's way forward, I think.
How much stress or strain is it on the driver? How physically, how strenuous is it?
There's a driver over there. Could you answer that, Chris?
Really depends how hard you push.
At the end of a race, is it like you've run 100 metres or 220 or?
Yeah, it would probably be worse than that, but it's all in the legs. So it's kind of a weird feeling when you get to the end and you don't feel tired, your body's still got energy, but your lower half is just pushed everything into it. So it's more an endurance of a particular part of the body. That's the difficult thing.
Some of the teams had two pilots, so we were really looking after this guy really well.
In your steering test, you overshot quite far. Would more ability to turn help you there?
I would almost certainly yes. Yeah, I think still we were doing pretty well compared with the rudder. I think. Would you say so?
You actually had a plan to get more steering.
Yeah. There was a plan. I just remember our brakes. Now, what we did with the brakes was when we could sniff the world record, we decided not to use them, and nobody showed up with any brakes anyway. So we taped over them, and they were basically not used. However, we did think that if we needed them, we could use one side at a time to steer the thing round, to essentially spoil the water on one side. If we had to get around a really tight corner, but we didn't have to do it in the end because we were able to get around with just the bending tail. Essentially, we had no rudder at all. We just had a bending body.
You got around, but as you pointed out, there's a bit of overshoot.
Oh yeah, there's overshoot. So we could, but that was the extreme case that was going on there.
It's also we would have tried extending the back tail, so the curve more, but we were the second fastest team around, and the fastest team was well ahead, which is the world record holders managed to get around. So there was no way we were going to catch them. because they were going faster on average than our propeller. And there was no way other people were going to catch us. So there was no motivation to try it. But you definitely could.
So apart from the turn of the tail, that looks very like a leather jacket's tail. But most fish have a fin that goes.
The leather jackets will they'll flare their tail up when they want to do that. That's a very good point. Very good point. Another interesting project. In fact, all fish will do. If you chase a fish, like I've been studying fish actually by chasing them and watching what they do. For example, a snapper. If you chase a snapper, its dorsal fin will fit into a groove. It'll fold its fins back basically and just use its tail for propulsion and go away from you. But when it turns, the dorsal comes up, the other fins flare out to give it some traction to go around. So fins are wonderful things. You can use them or fold them away and not use them. So that's another really good thing about fin propulsion.
So I noticed that your average speed went up every day of racing pretty much. So was that just getting used to the course, or did you make changes?
Well, we thought we were going to do 3.65 knots, maybe a little bit faster. In fact, I actually thought we were going to go slower because of this thing and the tail changes. But what was happening was a combination, I think, of our confidence. But we did do some good things. We made the dive planes a lot smaller. We had less drag from that. We were looking at we started looking for every crack on it and taping it up. And I think one of the most important things was we did something to tune those little Hobie fins. I think they were a bit they were too loose, yeah. And it could have been that maybe we could have gone faster in Carderock if we paid more attention to that. But we seemed to hit a really nice result with our two fins. And then suddenly we were into the 4+ knots after doing that. So I don't think we could have gone much faster than we did, but without a smaller hull, frankly. But I think we got them pretty right. They have to be, you don't want them too stiff, otherwise they won't curve around as you do this and provide a forward lift vector. And you don't want them too loose either. Then they don't do anything. So you got to find that sweet spot between the two.
Well, how are they adjusted?
There's a little screw in the bottom that provides tautness to the rubber. Pulls the whole membrane more stiff. It's got a rod that the thing fits over, but then you can pull down on the trailing edge at the bottom with this little screw mechanism that tautens up the whole thing.
So if you change the design of those fins, will it give you more thrust?
Improve the design of them.
Can you get more thrust out of them by changing the design sometimes?
We have a model for this, and we started looking at that, but we didn't get far enough down the track with it. I think you're probably right. However, don't forget that we bought them from Hobie, and I'm imagining Hobie's done some work with them. I mean, they seem to work pretty well. But some basic calculations we did indicate we could probably do slightly better than what. But
you didn't put your file on a training program.
Yeah, one of the problems is that you don't forget you're coupling this to a human, and if you might have a better performing fin, but then it's going to be something which is going to fatigue your legs. I used to have a pair of dive fins who were quite stiff, and you could produce really good thrust with them, but I kept on getting cramp all the time. And now my favorite fins are quite floppy, rubbery things that don't produce a lot of thrust, but I never ever get a cramp.
So this on a more general note, so what is the motivation for all these groups working on human-propelled submarines? Is it just interest, or is there
Well, it's my own passion is to demonstrate that fin propulsion's very good, and I think we've done that. But I guess one of the big driving forces for the team is it's just bloody a lot of fun. It's just a lot of fun. I mean, we actually, you're doing something which is really difficult, but if you get it right, it's beautiful.
Great learning opportunity.
Yeah, yes. You actually experience hydrodynamics. You don't just see it on a video or watch a model. You're actually part of it, and that's the wonderful thing about it. And there's been so much that we've learned, and you get to meet some really nice people too. The ETS team had some serious breakdown problems during that week with their. They also had the fin drive. They were just walking over to us and saying, "Oh, you should tape this up here." They were actually telling us how to go faster. It's a wonderful group of people to be with. The whole community. It's like flying was in the 20s, I would imagine. It's sort of but it's underwater. So it's just like that. I could imagine what it was like in England in the 1920s when they had those crazy weekend meetings of every form of flying machine.
All right, so let's thank Ian again for a wonderful talk.